All right, so at the end of the last video, or in the last video, I guess we worked a problem on Gaussian elimination. Um, and so what we're going to do here is talk about something a similar method for solving these called Gauss-Jordan elimination. And with Gauss-Jordan elimination, with Gaussian elimination that we did in the last example, you get the matrix to row echelon form, and then you can back substitute. With Gaussian, we are getting to reduced row echelon form. And if you remember, echelon form is looking like this, where you have the leading entries are 1, anything below those in the same column would be 0. With reduced row echelon form, any leading entry is the only non-zero number in that column. So only non-zero number for each column. And with Gauss-Jordan elimination, you get the matrix to reduced row echelon form. And then the answer is actually just right there in front of you. So it's a couple more steps to get there, but when you get there, you're done. So with row echelon form, you have to do the back substitution. With Gauss-Jordan, you don't have to do the back substitution. So this is the same system that we had in the last problem. So let's go ahead and write the matrix that we ended up with. So we had 1, 2, -1, 1, and 0, 1, 4, -7, and then 0, 0, 1, -2. And so that is the same equation or same matrix we had right here. And so we're just going to start there. That's in our row echelon form. And we're going to take this and bring it to reduced row echelon form. And so now what we need to do is we need to get zeros in these 3 spots, and that will put us in reduced row echelon form. So we're going to work with, this is kind of our anchor here. So to get this one to be a 0, we're going to multiply row 3 by -4 and then add it to row 2. So row 2 -4 times row 3. And then we're also, to get this one to be 0, we need to add row 1 plus row 3. So 1 plus 3. And then maybe I should have switched those around, but row 1 plus row 3, that's going to replace row 1. So 1 plus 0 is 1, 2 plus 0 is 2, -1 plus 1 is 0, and then 1 minus 2 is -1. Row 2, we're going to do this row minus 4 times that row. So we still have a 0 there. We still have a 1 there. 4 minus 4 times 1 will give us a 0. -7 minus 4 times -2, that's going to give us a 1 right there. And then row 3 is going to stay the same. And so we're almost there. Now we just need to get rid of that one, make that one be a 0. And so we have to work with row 2 and 3, or sorry, row 1 and 2. And so this would be, we can multiply row 2 by -2 and add it to row 1. So row 1 minus 2 times row 2. So 1 minus 2 times 0, that leaves a 1. 2 minus 2 times 1 is 0. 0 and 0, nothing to do there. -1 minus 2 times 1, that gives us a -3. And then we have 0, 1, 0, 1, and then 0, 0, 1, -2. So now we're in reduced row echelon form. So all of our leading entries are the only non-zero numbers in those columns. And so now, if we were to write this as, go back to writing it as equations, we'd have z equals -2, we'd have y equals 1, and we would have x equals -3. And then that is the same solution we got before. And so you can see it's a couple more steps, but I guess it's the same amount of work. It just kind of depends on your preference if you want to do this extra part with the matrix, or if you want to get to this part and then do a back substitution. I don't think there are any problems on WebAssign where they force you to do it either way. I don't know that they really could force you to do it one way or the other. They suggest one way or the other way, but I really don't think I don't think it matters. You can do whichever method you prefer. All right. So this part you may remember from algebra class when we study systems of equations. So in a system of equations, linear equations, the examples we've done so far where we find a solution, and that is the solution to the system. There's no other solution. Those are called independent systems where there's one solution. But you could also have no solution. So no solution is where you end up with 0 equals a non-zero number, essentially. And so what that looks like, we can see that down here. You get this to row echelon form, and then this column, if you were to write that as the actual equation, or this row, sorry, this row written as the equation would be 0x plus 0y plus 0z equals 1, which obviously has no solution. So anytime you have the variable columns are zeros, and then the right-hand side column is not a 0, then there's no solution. One solution, that's when we can just get it to a row echelon form or a reduced row echelon form, where each row has a leading entry, and then it works out. And then we can have infinitely many solutions, and so this is called dependent. So we have inconsistent when there's no solution, and then dependent is where there are infinitely many solutions. And what this looks like is when you have a row with all zeros. Anytime you have that, that will tell you that you have infinitely many solutions. We'll see an example in a minute for what that looks like. So let's look at this example here. So solve the following system. And so let's write the augmented matrix. So we have 1, -3, 2, 12, 2, -5, 5, 14, 1, -2, 3, 20. And so let's just start by getting zeros in these two entries, and then we'll work on that one after that. So let's write the first row. And then let's do -2 times row 1 plus row 2. And so -2 plus 2 would give us a 0. -2 times -3 minus 5, that would give us a 1. -2 times 2 plus 5, that would give us a 1. -2 times 12 plus 14, that would give us a -10. And then we can just subtract row 1 minus row 3. So that would give us a 0 there. -3 minus -2 give us a -1. 2 minus 3 give us a -1. And then 12 minus 20 would give us a -8. All right. And then now we want to get a 0 here. And so we can just add row 2 and row 3. So let's copy rows 1 and 2. I'm not working with them right now. And just do row 2 plus row 3. And so it'd be 0, 0, 0, and then -10 minus 8 would be -18. And so we have the zeros for the variables and then a non-zero entry at the end. So that means no solution. And that's as far as you need to go. Probably they like you to divide by -18 to give you a 0, 0, 0, 1, but you don't have to do that. That doesn't matter. All right. So we'll stop this one and we'll look at a couple more examples in the last video.